Okay. In this type of inequality, the strategy is the same. The strategy being the first thing we do is get everything
On one side.
on one side, and so that's equal to 0. And then we solve the resulting equality.
Yep.
In other words, we're going to set the numerator equal to the 0 and the denominator equal to 0. That tells us how to divide the number line. The important thing to be careful about is the denominator solutions. Those always show up as wholes.
Yeah, because it's undefined.
Right. And if it's not a strict inequality, in this case, the numerator solutions will be colored in dots. Okay. And then test the regions and translate the results. Okay. So first part, we have to be careful to not mess up, basically. So we're looking at 7x over x minus 2
minus 6.
Let's go ahead and prepare this for battle with the other fraction.
Yeah, so you can get a common denominator.
I'm going to go ahead and put this equal to 0. I'm not messing with an inequality past this point, because when I go to test my inequality, I'm always using the original. Because if I start doctoring this inequality, who knows how I might screw up. So I'm always testing the original results. Okay, so this becomes 7x minus 6x minus 12. Again, the brackets are for quality control purposes. Meaning I kind of don't want to screw up this negative there.
So you end up with x plus 12 over x minus 2 is equal to 0.
Okay, and the rest gets somewhat easy, because now I guess I'm skipping a little bit. I need to have x plus 12 equal to 0 and x minus 2 equal to 0. The x minus 2 came from the denominator, which means I need a whole at x equals 2, and I need a colored in dot at x equals negative 12. Okay. Now what? Test the regions.
Yes.
I'm a big fan of 0 and
negative 1 trillion.
X equals negative 10 to the 9th.
Yeah.
And X equals positive
10 to the 9th.
10 to the 9th. Okay. So at 0, we're going to get testing our original inequality, plugging in 0. We'll get
it works.
It works because we'll get 0
is less than or equal to 6. Which is
0 over negative 2 less than or equal to 6. So this whole region right here is good. When x is 10 to the 9th.
That does not work.
Right, we'll get 7 trillion over a trillion.
Yes.
Right, so 7 times 10 to the 9th over approximately 10 to the 9th, which is about 7.
Yes.
Which is bigger than 6. So this is actually a little tricky. So this is bad. And to the left over here, we'll get negative 7 times 10 to the 9th over negative 10 to the 9th.
And that doesn't work either.
Approximately 7, which is quite bigger than 6.
Most days.
Bad. Okay, put it all together, and we have closed brackets here
and
open brackets there.
And that is the answer in interval notation.
There we go. Okay, so this is actually tricky. If you remember that remember from your previous studies, this thing right here has an asymptote at 7, a horizontal asymptote at 7, as we go both to negative infinity and positive infinity.
Yes.
That's essentially what we're discovering down here when we plug in a trillion. Okay?